Hello, and welcome to the Introduction to PG Nitrous webcast. My name is Andy Ellicott from Swarm64, and our agenda today includes the following. First, I'll explain what the PG Nitrous Postgres Cloud service is all about, what it is, when to use it, why to use it, how it works. Since PG Nitrous is relatively new, I'll also cover the product roadmap and how the PG Nitrous Cloud will evolve over the next few months. We'll wrap up with a Q&A session, and since one of the most common questions we get is whether the slides will be shared with attendees, I'll answer that now. Yes, we will share a link to the slides and recording of this webcast after the event's over. Expect that later today or early tomorrow. Before we get into PG Nitrous, let me introduce you to Swarm64, for those of you who aren't familiar with us already. We're mainly based in Berlin, Germany, and Boston, and we're in the business of making Postgres go faster. So we're the developers of PG Nitrous, which we're talking about today, and also the Swarm64DA Postgres extension. Swarm64DA speeds up Postgres query performance by enhancing the database with greater parallelism, columnar storage, faster join algorithms, better query plans, and more. It's really what gives PG Nitrous its query performance advantages. So what's PG Nitrous? So it's a new Postgres cloud that's made for people who want standard Postgres, but with much faster query performance. It's a Postgres 12 database instance hosted on Amazon EC2 that offers about 30x faster query performance versus Amazon RDS or self-hosted Postgres. The chart on the left shows TPCH query benchmark results at around 1 terabyte of data, or scale factor 1000. It's PG Nitrous, the short orange bars, versus Amazon RDS, the tall blue bars. And I'll explain that benchmark in more detail later in the presentation. But basically, it's kind of shows how much less time the TPCH queries take with PG Nitrous, about 30 times faster overall for the whole benchmark. With PG Nitrous, you'll have full admin rights to your Postgres database, even the ability to install other extensions if you wish. It's something that Amazon RDS doesn't support. And of course, all of this is backed by and supported by the performance experts at Swarm64. All right, let's talk about use cases a little bit. So with faster query performance, PG Nitrous is a great choice for query-intensive database workloads, such as database applications that support lots of users running queries, okay, reporting or interacting with data dashboards and data visualizations and such. PG Nitrous can help you give them faster answers and support many more concurrent users, often around 5 times more concurrent users than a standard Postgres or RDS instance. Another good application of PG Nitrous is for data marts and data warehousing, especially if you're looking to modernize your data warehousing and analytics platforms by replacing legacy databases like Oracle, DB2, Netezza, and others, which are really expensive, with free open source Postgres on the cloud. PG Nitrous gives you the performance of those legacy databases, but a small fraction of the cost. And finally, if you're inclined to solve query performance problems or provide better query performance to your users by creating replicas of your base Postgres tables and to support the querying portion of your application workload, PG Nitrous is a great replication target. Okay, you can replicate data into PG Nitrous as you would any read replica, Postgres or RDS, and the resulting replica gives you much, much better price performance. Okay, so we realize there are a lot of RDBMS options in the cloud, even many Postgres cloud options from which to choose. So how does PG Nitrous really compare? Fortunately, it's a pretty straightforward comparison and decision. It's really all about query performance. It's kind of like the Goldilocks and the Three Bears. Hopefully that fairy tale analogy plays well internationally here for audience. But Anyway, if you're on RDS and your query performance is too slow, just like porridge that's too cold for the bear, PG Nitrous is a much faster option, and it's very cost effective. About the same price as RDS or even less, and definitely less costly than Redshift, which some Postgres users will turn to for query intensive use cases like the ones I just described. You know, if Redshift is too expensive and RDS is too slow, PG Nitrous is kind of like the just right porridge temperature, okay? Much faster than RDS and quite a lot less expensive than Amazon Redshift. Okay, so earlier I made the claim that PG Nitrous runs queries about 30 times faster than our Amazon RDS, and here's where I get that from. So if you're not familiar, TPCH is a benchmark that's been used for the last, I don't know, 20 years as a basis of comparison for data warehouse type workloads, query intensive, workloads that analyze customer order data, right, at different scale. What we've chosen is a 1 terabyte scale, or also known as scale factor 1000. And what you're looking at here, each on the x-axis is each of those represents one of the queries in the benchmarks, right? There are 22 queries in all. And this is the performance. And what you're seeing on the y-axis is the number of seconds. Okay, so what you're looking at is, firstly, PG Nitrous completed all 22 TPCH queries. Overall, when you look at the total time it took for the benchmark, all 22 queries to run, Nitrous is about 30 times finished 30 times faster than RDS did, and also about the same if you're comparing self-hosted Postgres on EC2. Okay. Individual queries, your mileage might vary, right? So, so not all these queries are the same, but the difference in query performance is anywhere from, 5x faster on Nitrous to 60x faster on Nitrous. But again, overall for the whole set of queries, it was about 30x faster. Another big benefit of PG Nitrous is cost, right? Or price performance. As you can see here in this comparison of annual total cost, right, really the storage and instance costs and kind of service on top of that, PG Nitrous provides really great price performance compared to RDS and Amazon Redshift. So these are configurations on which we ran the 1 terabyte TPCH benchmark I showed earlier. The two columns on the left, the orange ones, are PG Nitrous. The gray column in the middle is Amazon RDS. And the yellow one on the far right is Redshift. So if we look at Nitrous, PG Nitrous compared to Amazon RDS, you can see that on a 16-core instance, costing about a third as much, about 2/3 less than the RDS instance. You're getting about 5 times faster query performance. If you run Nitrous on the same 48-core instance as RDS, you get a 24x faster speed up. Okay, so kind of choose you can kind of sort of optimize for either cost savings or performance, right, depending on your application requirements, and we can provide you with advice on how to size your PG Nitrous instance, but for your workload. But again, very, very significant difference in price performance. And if you comparison to Redshift, which people sometimes use for query intensive workloads, for this use case, 1 terabyte TPCH, we use the 48-core Nitrous instance performance, which was comparable to Redshift, slightly slower overall, but there were queries that, I think maybe 3 queries that Redshift just timed out on. Again, PG Nitrous completes them all. And but as you can see here, PG Nitrous is a big, about half, is a little less than half the cost of Redshift. So PG Nitrous really allows you to lower your cloud costs and deliver better performance to your users. Okay, so obviously performance varies depending on the on your application and your database. But here's some things to keep in mind, some rules of thumb we offer to help people set people's expectations on performance. Number one, the bigger your data problem, the bigger the benefit. Okay, if you have a lot more data than you have RAM available on the system, you're going to have a better, you'll have a more noticeable result, right? Versus running PG Nitrous on a database that fits entirely in memory. Okay, that'll be fast on no matter what you choose. Okay. Also, if your queries are taking hours and you want them to take minutes, or minutes and you want them to take seconds, that's the kind of performance expectation. You'll be happy with the result. Okay, if you're trying to take sub-second to faster sub-second, results there might be mixed, but we're really solving bigger data kind of problems. The second thing to keep in mind is that queries that benefit from parallelism in Postgres by having more parallel workers, okay, on just standard Postgres, will benefit greatly from PG Nitrous. Okay, we really make the parallelism in Postgres better. Okay, so which you'll see, and I'll explain this in more detail, but with PG Nitrous, we keep queries, query processing parallel longer throughout the query lifecycle. We also allow you to apply, up to, kind of generally speaking, about 5 times more parallel workers than Postgres limits you to. And it scales with the number of cores. So as you add cores to your instance, you're going to see kind of a linear improvement in query processing. Okay, unlike Postgres, which will plateau after a certain number of cores. And we really recommend, and this is actually why the kind of minimum node for or instance type for PG Nitrous is a 16-core server. Okay. And lastly, just in terms of database size, PG Nitrous is really great for terabyte scale databases, well into the terabytes. It's one thing to keep in mind that the maximum database size for PG Nitrous is half a petabyte. So anything bigger than you're looking at either having to shard very large shards, or kind of deal with or use a service that supports larger databases than that, like Redshift. Okay. All right. So now let's look under the covers and see how PG Nitrous speeds up Postgres queries. The first thing we'll look at is how to launch PG Nitrous. Okay, it's very simple to do, either following the links from swarm64.com or just going to the AWS Marketplace. You can search for Nitrous and launch an instance from there. Okay, just follow the prompts, which will really guide you through choosing an instance size that matches your workload. And in about 5 minutes of answering questions, you'll have and the Marketplace launcher doing its work, you'll have a PG Nitrous Postgres database instance ready to load and query. Right, so you'll be up and running in minutes. The EC2 instance, the Postgres database server, and your storage are all pre-configured for you to handle query-intensive workloads. So should be ready to go and get fast query performance right away. PG Nitrous is free for the first 30 days. Okay, after that, you'll be charged via your Amazon account. So kind of all the billing is handled through Amazon, not directly through Swarm, which makes it easier for most people to purchase. And keep in mind that the EC2 portion of this, right, so the Amazon's piece is not included for free during those first 30 days, right? It's a small EC2 fee, but if you want or you're interested, we have free Amazon credits that we can give you to cover the cost of EC2. Just ping us through the Swarm 64.com website or email me after this. I'll share my email contact information, and we can give you Amazon credits to cover those costs. Okay, now I'm going to explain how PG Nitrous delivers such fast query performance. Firstly, Nitrous is a Postgres 12 database that's accelerated by the Swarm 64DA extension. That extension enhances Postgres with better query planning and execution, column store indexing to reduce I/O, greater parallelism to take better advantage of your hardware, and faster join algorithms and more. And now I'm going to talk about these in a little more detail. Okay, so firstly, here's a representation of the Postgres query engine in PG Nitrous. Okay, on the left side, the interface is standard Postgres, so your Postgres code and tools will keep working with PG Nitrous just as they do with regular Postgres or RDS. Just query performance is going to be a lot faster. And internally, the first thing PG Nitrous does is take advantage of Postgres's amazing extensibility to provide the query engine with better statistics and costs, query costs, query plans, and from there, just Postgres does what it does. It'll choose, if PG Nitrous offers the query engine a better plan than native Postgres would have on its own, Postgres will use that plan, and if it doesn't, it won't, right? So performance can really only get better than native Postgres, okay? And a better plan based on better statistics can make a huge difference in query performance, okay? So secondly, PG Nitrous speeds up I/O, mainly through the column store index, which I'll explain in a minute, but also through faster scanning algorithms and some things like that we've implemented. And then lastly, as I mentioned, PG Nitrous really boosts the parallelism throughout the query process, even implements faster, more memory efficient join algorithms that enable you to join billions of rows quite fast and with less RAM available. Okay, the first thing I'm going to do is kind of explain a little more detail on column store indexing. Okay, so columnar storage is by now a pretty proven way to speed up query performance. Really first introduced popularly about 15 years ago through Sybase, Vertica, and some others really kind of started the columnar database, I think MemSQL and others, which are kind of natively and kind of purely column store databases, offer very fast performance. Okay. Another way to implement columnar storage is through foreign data tables, okay, which actually SwarmDA used to do. I think Citus data still does. But those require you to kind of store data in a either duplicate your transactional data in either a separate columnar database like Vertica or in a separate format in a foreign table like with Citus. But we've taken we've re-implemented our columnar storage recently as a column store index. The big benefit of this is two things. Number one, obviously the faster performance by reducing I/O so much in these compressed columnar indexes. But the other benefit is these are indexes attached to your base tables. Okay, so they're transaction safe. They don't require you to duplicate data. No extra ETL, no extra storage, no extra database. Right? For this, it's all kind of within your primary Postgres database or applied to a replica if you want. Okay, really implemented this kind of a la Microsoft SQL Server's column store index. If you're familiar with how that works, it's quite similar to that, or similar to Oracle's in-memory column store. Okay, you can see the create table syntax here. Okay, you can create each index can index up to 32 columns of your table. If you need to index, if you have a super wide table and you want to index more than 32 columns, you just simply create multiple column store indexes on that table with different columns in it. And again, these are compressed. Right? One of the things you can do is play around with the compression level. We've got some blog posts on how that affects the performance and storage costs and things like that. But accepting the defaults is usually, the net is accepting the default compression setting is usually the best. Okay. And the indexes are updated, created as soon as kind of vacuum the database. If you have auto vacuum set, the databases will be updated. I'm sorry, the index will be, the COM store indexes will be updated with changes to the base table every time auto vacuum executes, and adds very little overhead, if any, to transaction processing speed. And the queries themselves, for data that hasn't been put in the index, we have a little, the queries will execute against obviously the data that's in the index, plus also data that hasn't been committed to the index yet. So, so you don't have to worry about, you know, the indexes are transaction safe, your queries are transaction safe, and really always up to date. Okay. And regarding parallelism, a little more detail on this. Okay, so on the left here, what you see is the anatomy of a query. On your left, you see standard Postgres query processing. The query starts off in parallel. Okay, those vertical lines, the initial scan and filter and the first join. But then after those parallel workers merge their results, any subsequent joins, sorting and aggregating, things that come a little further down the road, are all done linearly, okay, and not in parallel. Okay, so the kind of parallelism comes to an end, and then it slows down as you kind of go through the rest of the query. As you can see on the right column, you can see that PG Nitrous keeps the query processing parallel throughout the lifespan of the query. Okay. And this is done by, and we also permit you to assign many more parallel workers to your query, or make those available. And it really scales up with the number of cores that are available to the system. Okay. So, you know, we'll support as many parallel workers as your instance's core count allows. This can be up to like 50 or 60 parallel workers on a query if you have the virtual cores to support it. Okay. And as I mentioned earlier, you know, faster join algorithms were built for parallel processing, and all of that really adds up to, again, contributes to the much faster query performance you'll see. Okay, so faster queries can actually translate into other benefits for PG Nitrous users. One of those has to do with concurrency, because this kind of benchmark shows with its faster, more resource-efficient query processing, PG Nitrous can support many more concurrent query users, like you might see in a multi-user reporting or analytics SaaS application. And this is another way you can keep your cloud costs under control as your business grows by, you know, supporting like 4 or 5 times more concurrent users with each Postgres server than you would before. So, you know, if you have large multi-user or a application that's growing very fast, it's a way to sort of cut your cloud costs by 4 or 5. Okay. So I mentioned earlier that PG Nitrous is a standard Postgres 12 database, and as such, it can talk to any Postgres-enabled tool or application. I also mentioned that a popular use of PG Nitrous is as a read replica for handling queries without slowing down your primary database, which is, you know, busy handling transactional updates and such. So as you can see here, PG Nitrous can be easily set up as a replication target using the same commands you'd use to replicate data from RDS Postgres or just native self-hosted Postgres database instance. Okay, so again, situations where you want a fast replica to handle the query part of your workload at a cost that's a lot less than some of the alternatives. PG Nitrous is a economic and easy choice. Okay, so last thing I'm going to cover is the PG Nitrous roadmap. If you're using Amazon RDS, probably one of the reasons you're doing that is because RDS automates a lot of the database administration. Okay, In 1.0 of PG Nitrous, we don't do as much of that. Okay, we do automate the configuration and installation of the database, for query-intensive workloads. And what we're working on now for delivery later this year and early 2021 is more of the automation of that database administration. So currently in development are, and currently expected, I think Q1 2021, are automatic backup and recovery, high availability configurations, and other things that will help make the administration and the operation of your PG Nitrous database easier and more hands-free. Okay, but until then, expect to do a little bit more administrative work, and again, you're backed up and supported by my colleagues, my teammates here at Swarm, to help you get through that. All right, so let's wrap up with kind of next steps. So I mentioned earlier how get up and running in about 5 minutes and for free for the first 30 days via the Amazon Web Services Marketplace. Just go to AWS Marketplace, search for Nitrous, PG Nitrous, and spin up an instance. It's free for the first 30 days, and then build your Amazon account if you continue using it beyond that. We have free EC2 credits to cover the EC2, the Amazon portion of your PG Nitrous experience for the first 30 days. If you want those, just ping us. We also have, as part of the installation, you'll find that there are some links. These are documented links to some benchmarking kits, right? So if you don't have your own data to play with and you want to use some of the benchmarks I described earlier, either TPCH or the TPC-DS, and I think actually the star schema benchmark is also included in there. Those are provided, so help you get started and playing around with PG Nitrous. Okay, so that wraps things up. I want to thank you all again for joining us today. Feel free to email me if you have any questions about PG Nitrous, and hope to see you online again in the near future at one of our other webcasts. Thanks again, and see you in the future. Bye.